Okay, so test for the level of potassium in the blood is not perfectly precise. Suppose that repeated measurements for the same person on different days varies normally with population standard deviation 0.2. So that means population standard deviation means we have sigma. So that means we're using Z. Later we'll get to when to use T. A random sample of 3 has a mean of 3.2. So sample of 3, that's our N. And the mean of that sample is X bar, 3.2. And what is the 90% confidence interval? So our critical Z for 90% is 1.645. We have that a couple pages back, or you can look at the bottom of your T table, right? 95% is T.025 all the way to the bottom. 90% we want, right? 90%, yeah. Okay, so T.05 all the way to the bottom, 1.645, so 90%. 95% would be 1.96, 98% would be 2.326, and 99% would be 2.576. So you can refer to that. So the confidence interval is the mean equals X bar plus or minus critical Z times sigma over root N. So we put in all of our numbers. X bar 3.2 plus or minus critical Z 1.645 times sigma is 0.2 over root 3. So what you want to type in is 1.645 times 0.2 divided by root 3. And that gives us plus or minus 0.1899. And to get the actual interval, if he wants it on the exam, we would do this minus this, comma, and then 3.2 plus this. So 3.2 minus 0.1899, 3.2 plus 0.1899. And that would be the actual interval. So type that in and see if you get 3.01 and 3.39 it should be. Okay, any questions about the first one here? Okay, Anna, the manager of a paint supply store, wants to estimate the actual amount of paint contained in 5-liter cans purchased from a nationally known manufacturer. So nationally known manufacturer, so that means we have a sigma. It is known from the manufacturer's specifications that the standard deviation is 0.1, so sigma equals 0.1. So since we know sigma, we're using Z. A random sample of 50 cans, so that's N, is selected, and the sample mean is 4.975. So what letter do you use for sample mean? Sample mean, what letter? So that would be X bar equals 4.975. Set up a 99% confidence interval. Okay, so look up your critical Z for 99%, either back a few pages or on the bottom of the T table. So it should be 2.576. So confidence interval is X bar plus or minus critical Z times sigma over root N. So we have X bar is 4.975 plus or minus 2.576 times our sigma, which is 0.1, all over root 50. So we do 2.576 times 0.1 divided by root 50. Do all of this first. And we get 4.975 plus or minus 0.0364. And then we do 4.975 minus this and 4.975 plus this. And work out your interval. Okay, so this minus this would give me 4.939, and this number plus this would give me 5.011. So on this basis, do you think the manager has a right to complain? So they say that the paint cans contain 5 liters. So if they're saying that they contain 5 liters, we want to say is 5.0 liters in our interval here. Well, it's between 4.939 and 5.011, so then 5.0 is in there. So then, therefore, they shouldn't be complaining. So think of it like H naught is mu is 5, and you're asking yourself about H naught. So this would be, if we were talking about hypothesis testing, it would be a do not reject H naught, because H naught mu equals 5 is in our interval. Okay. So number 3, 95% confidence interval for mu with sigma known was determined to be 18.52 to 21.48, based on a sample size of 50 drawn from normal population. What is the population standard deviation? Okay, so 95%. So look up your critical Z on the bottom of your t-table for 95%. So it should be 1.96. We have a sample size of 50. So what letter is that? Sample size of 50. So that's our n. And we can calculate the width of the interval by subtracting the two numbers, the larger minus the smaller. So 21.48 minus 18.52. And that gives us a width of 2.96. So think about, how do you get the margin of error if you've got the width is 2.96? How do you get the margin of error? So the margin of error is the width divided by 2. So 2.96 divided by 2 would be 1.48. Now, the margin of error formula is the critical Z times sigma over root n. And we have everything that we need to be able to find the population standard deviation, which is sigma. So E is 1.48. Critical Z is 1.96. Sigma over root 50. So to solve, we could do 1.96 divided by root 50. And then divide both sides by the number in front of sigma. And you should get sigma is 5.3. Now, a common exam question is asking you to find a sigma, so using something like example 3, but also number 4 is really common, where you're given a certain confidence interval and you're asked for a different confidence interval. So you're given a 95%, you want a 90, or you're given a 99 and you want a 95, or something like that. So you don't need the X bar in the formula at all, so you wouldn't use the X bar plus or minus because you're trying to find sigma. So you couldn't use the X bar plus or minus because then that would not be finding the margin of error. So we have E, we need E in the formula. And the regular X bar formula, you know, you're finding a confidence interval when you do that, okay? So you would just use this one. X bar is not involved. You're right, X bar is the middle though, but you don't need it in this question. You need to find sigma. Okay, so find a 90% confidence interval. So we have a 95%. And we want a 90%. So the formula, you have your new margin of error is your old margin of error divided by the old critical Z and times the new critical Z. So this is a formula to memorize that will help you get from one confidence level interval to a different confidence level interval. So the old one, we had 95%, and the new one we want, in this case, is 90%. This will, of course, what I put in pink will change in every question, right? So the margin of error up here we have is 1.48. So we have 1.48. Critical Z for 95% is 1.96. Critical Z for 90% is 1.645. And that gives us 1.24 of a new error. So we have our interval 18.52, 21.48. We have our X bar is the middle. Go ahead, calculate the midpoint of this. So it should give you 20. So the new confidence interval will be X bar minus E and X bar plus E. So here's the E right here, and here's the X bar. So we have 20 minus 1.24 and 20 plus 1.24. And that would be our new interval. Okay, any questions? Okay. Which of the following will decrease the width of a confidence interval? So we've got critical Z times sigma over root n. That's our margin of error formula. Okay, so margin of error is the critical Z times sigma over root n. So which of the following would decrease the width of a confidence interval? Well, you should know this because we talked about this at the very start. So write down what you think. All right, so if you're decreasing the width, then you're decreasing the margin of error. So E is going down. So which of these would make the margin of error go down? Well, as sigma goes down, the margin of error goes down. As Z alpha over 2 goes down, the margin of error goes down. And as N goes up, the margin of error goes down. So increase the sample size, that's true. Increase the level of confidence, that's not true. Okay, that's opposite. We would decrease the level of confidence to get a lower width. And decrease the population variance or the population standard deviation, that's true. And that's false because we already said increasing was true. So it'd be 1 and 3. So B. Okay, what is the critical Z for a 97% confidence interval? Okay, so draw out and label 97% in the middle. So what you have to remember when you're looking up the critical for 97% confidence interval is you're not looking up 0.97, okay? So that's the first thing to know. If you're looking at 0.97 and doing a 97% confidence interval, then you're making a mistake. Your confidence interval is the middle part here. That's the 97%. But the number that you can look up on the actual Z table is either the area below this line or the area below that line. Those are the two numbers that you can look up on the Z table. The Z table looks up the area below your line. So if you have 97%, that means you have 3% left. 0.03 divided by 2 is 0.015 on each side. So you can either look up 0.015 and then whatever number you get, just make it positive. Or for me personally, I think, okay, if I have 0.015 above, then this in here is 1 minus 0.015 or 0.985. So get out your Z table. And find 0.985 or the closest number to it in the body of the table because it's an area. Okay, so 0.985. So that's right there. So it corresponds to 2.1 and 7 there. So 2.17. 2.17. So A. Okay, so again, keep in mind you draw the middle at your confidence level, but then make sure that you find the total area below your line, and that's how you look it up on the Z table. And you know that, a 95% is 1.96, so you can kind of eyeball approximately, right, to make sure that your answer makes sense, okay? Because you do know the numbers for a 95% and a 98% and 99%. Okay. Example 7, a company makes screws that are supposed to have a length of 1.3 millimeters. Every day, the company tests a random sample of screws. Yesterday, a random sample of screws gave a 90% confidence interval of 1.28, 1.34. Okay, so which of the following is correct? So we have to ask ourselves, is our H naught in here? Okay, so is 1.3 between 1.28 and 1.34? Yes, right? So that would mean fail to reject H naught because H naught is 1.3. So we're not going to reject H naught. Okay, or do not reject H naught. Now, 90% confidence interval means alpha is 10% level of significance. So if, this is kind of leading into the next section on hypothesis testing, but if your p-value is less than or equal to alpha, then we reject H naught. If your p-value is greater than or equal to alpha, then we fail to reject H naught. So this you're going to have to memorize when we get to hypothesis testing, which will be shortly. For now, just write it down and you'll be going through what a p-value is shortly. P-value is basically the area under the Z that you draw out. Okay. But what we need to know here is at the 10% level of significance, if we failed to reject H naught, then that means our p-value is greater than our alpha. Since we said fail to reject H naught, our p-value is greater than alpha. So therefore, at the 10% level, since we failed to reject H naught, that means our p-value is greater than 10%. Well, if our p-value is greater than 10%, then our p-value would have to be greater than 5% as well. If it's already bigger than 10, then it's greater than 5% too. So our answer would be, we would fail to reject H naught at, if you look up, it would be at both the 5 and 10% levels. It would be A. Because if our p-value is already greater than 10, then it's definitely greater than 5. So that would be answer A. Okay, questions? Question gave a p-value at 10% and asked for the 5. Would we divide or by 2 and multiply by the new one? No, so you can't work out a p-value based on these. So so you wouldn't be able to conclude. If it was the other way around and you had p-values greater than 5 and you wanted to know if it was greater than 10, you wouldn't be able to tell based on the numbers, basically. 95% confidence. Well, if it's 95% confidence, then alpha would be 5%. Okay, any other questions? Okay. So next is finding sample size. So sample size is turn to page 103. So the sample size formula is kind of in the middle of 103 near the top here. So critical Z times sigma over the error all squared. And that's just this formula rearranged. So they do tend to give you this on the exam, so you can check, your formula sheet that's on your OWL to make sure it's on there. But it does tend to be given to you every year. And one thing we need to remember is that when we're finding sample size, we always have to round up. So that's at the bottom of your page. So we always round up. Even if we had 24.1, we would still use n equals 25. Otherwise, you wouldn't have the right level of confidence if you didn't round up. So if you rounded down to 24, then you would find if you recalculated, you wouldn't have, let's say, 95% confidence. You might have 94 point something % confidence. If you're given the width of the confidence interval is 10, then make sure you know the margin of error would be 10 over 2, which is 5. The margin of error is what you actually need for the formula, not the width, okay? So make sure you always have your margin of error. Okay, so suppose you want to construct a 99% confidence interval with the width of no more than 5 and a population variance of 38. What is the minimum sample size needed? Okay, so write down for me what you know from this question so far. Write down what you know. So we know 99% means our critical Z is 2.576. Again, you can get that at the bottom of the t-table. We know that our width this time is 5. So our margin of error would be what? Write down what you think. What's your margin of error? So it would be the width divided by 2, which would be 2.5. And we know that the standard deviation squared is 38. So the standard deviation would be root 38, or 6.16. So our formula is n equals critical Z times sigma over E all squared. So we put everything in, 2.576 times sigma 6.16 over E 2.5 all squared. So to type this in, type in 2.576 times 6.16 equals, divide by 2.5 and then hit the squared button or the y to the x2 button, whatever you have for squaring. And it should give you 40.3 and therefore round up to 41. So B. Okay, any questions? So, as I said at the start of this section, we always round up for n, always, because if we don't round up, we won't have the desired confidence. If you round this down to 40 and you recalculate your confidence level, it will no longer be 99%. So you have to always round your n up to get your desired level of confidence, okay? You can't round down. The exact answer is 40.3, but of course, we can't have a sample size of 40.3. Okay, a 97% confidence interval from you with known standard deviation was constructed based on a sample size of 100. So sample size means what letter here, guys? So that's n. If you want to construct another 97% confidence interval twice as wide, how many observations do you need? So we want it to be twice as wide. So n does what so that the error goes up by 2 times. Think about what your n has to do so that your error goes up by 2 times. So n has to go down by 4 times so that the error can go up by 2 times. Remember we said they're related by a root, right? So if we want it to be twice as wide, that means the error has to go up by 2 times. That means n has to be decreasing by 4 times. Okay? So 100 divided by 4 is 25. So A. And that's since the root of 4 is 2. Okay, now what happens in a question if they don't give you the standard deviation? Then you do have a way to estimate the standard deviation, okay? So the estimate of the standard deviation is the range divided by 4. And this is something that isn't typically on your formula sheet, so you do usually have to memorize this in case they ask it. So a feed company has developed a new feed supplement to promote weight gain in cows. They wish to construct a 90% confidence interval with the width of no more than 8 kilograms. They expect the cow's weight gain to range from 35 kilograms to 120 kilograms. How many cows do they need to sample? Okay, so first of all, let's see what we know here. We know it's 90% confidence interval. So write down your critical Z for 90%. So that would be 1.645. Then it says a width of no more than 8. So what's our E here? So our margin of error is width divided by 2, which would be 4. And then it says the range goes from 35 to 120. So we do max minus min to calculate the range. So that would be 85. So our estimate for sigma is range over 4. So 85 divided by 4 is 21.25. And so now we can do our N formula, critical Z times sigma over E, all squared. So go ahead and tell me what your sample size would need to be here. Okay, so this would be 1.645 times sigma, 21.25, all over margin of error, which is 4. And then once you divide by 4, you've got all this typed in, then hit the square button. It should be 76.4, so therefore always round n up. So 77 counts. Okay, so we're going to start on some hypothesis testing, and then all day tomorrow will be confidence intervals and hypothesis testing. Okay, any questions about finding the sample size here? Okay. So hypothesis testing is on page 109. Okay, so a hypothesis is a claim or a statement about the population. So we might state H naught, the mean is 12. And then we state some alternative. The alternative could be that mean is not 12. That would be called a two-sided test. Or it could be mean is less than 12, or mean is greater than 12. Those would both be called one-sided tests. We call H with the little 0, we call this H naught. And this is HA, which is the alternative. And that's what we're testing for. So we're trying to see if there's evidence against H naught, okay? So we either reject H naught or we don't reject H naught. We're never rejecting HA, it's always to H naught. If we have a two-sided test, then we have to double our p-value. So when we draw the graph, we'll have a p-value on both sides. Anytime you see a not equal to, that could be something like different than, or it could say whether or not, sometimes they say, whether or not the mean equals 12, something like that. So the burden of proof falls on the alternative. We assume the null is true unless we prove otherwise. So you have to look for keywords like greater, less, more, things like that. Just see whether it's one or two-sided. Your conclusion is always, if the p-value is greater than alpha, then you fail to reject H naught. And if the p-value is less than alpha, then you reject H naught. So write that down, p-value less or equal alpha, reject H naught. And that means that there is statistically significant evidence that HA is true. So that means the test is statistically significant. And it means that X bar is plausible. In other words, likely to be true. So those are all kinds of conclusions that you can draw from saying p-value less than alpha, reject H naught. Okay. So what if the p-value is greater than alpha? Well, then this means to fail to reject H naught. And that means there is no statistically significant evidence that HA is true. And that means the test is not statistically significant. And it would also mean that X bar is not a plausible value. Mu, or mu naught, is likely true because you're failing to reject H naught. So those are all the conclusions that we can make based on a hypothesis test. So whether or not it's statistically significant or not, and whether or not X bar is plausible or likely value. And again, if you're saying fail to reject H naught, then you can say that mu is likely true. Just wait a minute to make sure everybody has it all written down. Okay. So your shading can go either on the left, the right, or both sides. So if it's a two-sided test, we'll have shading on both sides. So for a two-sided test, we have p-value on both sides. If it's just a less than test, then we just shade below Z test. And if it's just a greater than test, then we just shade above Z test. So this would be the shading for less than test. We would shade below Z test. And we'll write this out as we do the examples. And our shading would be over to the right if we're doing a greater than test. Now, you have from your notes, you have what the test requires. So you need to memorize these different levels and the levels strong, very strong, some, all of that. And then you have your conclusion based on the p-value. Sometimes they call it mild. Sometimes they'll say mild bracket some, so both. And keep in mind that your alpha ranges from 1 to 10%. So if your p-value is less than 0.001, you have extremely strong evidence against H naught. If your p-value is less than 0.01, so these are all less than, then you have very strong evidence. P-value less than 0.05, then you have strong evidence, and p-value less than 0.1, you have some mild evidence. You can do these as ranges, so sometimes they write them as a range between 0.001 and 0.01, between 0.01 and 0.05, etc. Okay. So a random sample of 30 is taken from a normal population with unknown mean mu with known standard deviation 18.5. The sample mean is calculated to be 108, and we wish to test the hypothesis that the mean is different than 100. Okay, so mean is different than 100. So let's write our hypotheses here. So first of all, we've got H naught mu equals 100. Some people put the little naught on the mu, so mu naught. Some people don't, so I've seen both, so whatever you're used to. And then it says different than 100. So different is two-sided. So when we have a two-sided test, this means that we're going to plot plus and minus Z test. So we're going to double the p-value on one side to get the total p-value. Now, what do they tell us? A random sample of 30, so n is 30. The sample mean is 108. And known standard deviation, so sigma is 18.5. And sigma means that we're using Z. Okay, so our Z test formula is the same formula that we used for sampling distribution. So it's X bar minus mu all over sigma over root n. So x bar is 108 minus mu, or this can be mu naught. The mean is 100 all over sigma 18.5 over root n, which was 30. So that's 2.37. So we've got to draw this out, and we've got to plot plus or minus 2.37. That's because it's a two-sided test, so we plot both. Now our p-value is the total area in here and in here. And they're symmetrical, if you can draw them symmetrically. So take out your negative z2 It's negative 2.37. So negative 2.37. 0.0089. 0.0089. So that's the area on both sides. So the p-value is 2 times 0.0089. So when would we reject and when would we not reject? Well, at the 1% level, this is going to be bigger than 1%. So at the 1% level, p-value is greater than 0.01. So that would mean fail to reject H0. But at the 5% level, this p-value equal to 0.0178 is less than 5%. So that would mean reject H0. So we can make different conclusions based on different alpha levels. So what would this be? You can reject at 5% but not at 1%. So this would be C. You could look up the positive, the area below 2.37 and then subtract from 1. But you couldn't just look up the area below the positive because that would be too big, right? You need the area above it. But yes, if you subtract from 1, then you can do that. Okay, questions? The critical method requires that you have an alpha given to you. So they'd have to say, like, here's your alpha. So yeah, we'd have to be given a specific alpha to be able to find the critical. Okay. So light bulbs with a stated mean lifetime of 600 hours have been stored in a warehouse for several years. A sample of 20 of these bulbs is selected and tested to see how long they last. The result of this sample gave a mean of 580 hours with a process, so process means population standard deviation of 30 hours. You wish to test whether prolonged storage has significantly reduced the life expectancy of these light bulbs. Assume a normal distribution. Which of the following are the correct, null, and alternative hypotheses? Okay, so look at the hypotheses and see what you think here. Okay, so it says the stated mean lifetime is 600 hours. So that's what we're looking at in terms of the hypotheses. So we don't want to look at the sample mean. The sample mean is 580. So these are wrong because these are sample means. So they can't be H naught if they're sample means. And we want to see if it's significantly reduced. So that means our HA has to be a less than or reduced. So that means it's C. So what do they tell us in here? They say a random sample of 20, so that's N is 20. Sample mean of 580. Process standard deviation of 30. So we know sigma, so we know we're using Z. And we know it's a less than test. So because we know it's a less than test, so less than test means we're going to shade below Z test. So sometimes they give you H naught is less than or equal to instead of equal to. A lot of times, I would say the vast majority of your exam questions will be equal to, but in this particular case, they gave exam questions that were not equal to. They were less than or equal to or greater than equal to. So as long as you know, like there's not going to be both, right? There's not going to be equal 600 and greater than equal to 600. Okay. So significantly reduced, we can get our HA from that. And so we know it's either equal or greater or equal. Yeah, so it's always a possibility that they give you, you know, 1 or 2 questions on the exam where they're not just a strict equal to. Okay, so if we want to find the p-value, we've got to do our Z test first. So we've got X bar minus mu all over sigma over root n. Okay, so put your numbers in and see if you can get your Z test, and then we'll talk about how to conclude based on it. Okay, so let's see what you got. So it should be 580 minus 600 divided by sigma is 30 over root 20. Should have given you negative 2.98. Now remember, this is a less than test, so we shade below Z test. So draw out negative 2.98. And we want to shade below it. So that's our p-value right there. So we get negative 2.9 across from to 9.8. We get 0.0014. So that's the area below, so that's our p-value. So our p-value is less than 0.01, so it'd be D. Now, if we go back to that conclusions based on it, so that would be extremely strong evidence against stage knowledge, according to your numbers there. Okay, any questions? Okay. So are you performing, oh, change that to Z test. For some reason I put T instead of Z there. So you're performing a Z test at the 5% level of significance. You obtain a p-value to be between 0.05 and 0.1, which of the following statements is true? Okay. So 5% level, and then p-value, 0.05 to 0.1. So I think I have the chart in the front of the book too. Yeah, so the test requires 5%, so the test requires strong evidence. And then the p-value, flip to that, between 0.05 and 0.1. So that would be greater than 0.05 would be less than 0.1, not less than 0.05. So less than 0.1 would be some, or sometimes they say mild evidence. Okay. So this would be strong for the test. And this would be some or mild. So the test requires strong evidence, and our data showed some mild evidence. So that would be B. Okay, so now instead of concluding based on p-value, you can also do the critical method where you look up the critical value based on your alpha. So we'll practice that a little bit today, and we'll practice it again tomorrow. So what are your rejection regions if you perform a two-sided Z test at alpha equals 8% level of significance? So if we have 0.08 divided by 2, that's 0.04 on each side. So we need to look this up. These are what we call our rejection regions. Now, if it was one-sided, then our whole 0.08 would go up here if it was a one-sided greater than test, and our whole 0.08 would go down here if it was a one-sided less than test. So we're dividing the 0.08 divided by 2 because it's a two-sided test. So this is because it's a two-sided test. If it were just a greater than test, the whole 0.08 would be drawn up here. If it were less than test, the whole 0.08 would be drawn down here. So we have to look up 0.04 in the body. Okay, so 0.04 in the body. So 0.04, I guess 0.0401 would be the closest to 0.04. So negative 1.75, negative 1.75. So that would be the positive 1.75 on the right. And so our rejection regions would be, we would reject H naught if your Z test was greater than 1.75 or less than negative 1.75. That would be your way to conclude if you were concluding. Okay, let's do one more and then we'll call it a day here. The last one is pretty hard, so I'd rather do it tomorrow when you're not tired in this section. So a 90% confidence interval is given as 28.2 to 35.6. Consider the following: H naught mu is 30 versus HA mu is not 30. H naught mu is 40 versus HA mu is not 40. Which of these null hypotheses would be rejected at the 10% level of significance? Okay, so let's see if you can make your conclusion here. Okay, so is 30 in our confidence interval? And the answer is yes. So that would be do not reject H naught for number 1. Now for number 2, is 40 in our interval? And the answer is no. So that would be a reject H naught for number 2. So reject in number 2, but not in number 1. So that would be C. Okay, well, great job today, guys. So work hard tonight if you can. If you need to have a nap first, maybe take a nap before you do any more math. But study hard, and I will see you back tomorrow at noon, okay? Take care, everybody, and stay on if you have questions.